So this video is for the 12 or so questions where you can use a calculator on this test. Exact numerical value does not always appear among choices. It's multiple choice. Make sure your calculator is in radian mode. So I'll do that. Okay, let's take a look. So the first question here, 76. Here's a table. They want the average rate of change. Average rate of change is basically like slope. So from 1 to 4, you do 10 minus 16 over 4 minus 1, which is 6 over negative 3, which is negative 2, which is the answer to that question. Officially, it's f of b minus f of a over b minus a. Question 77. This table shows the length of a high-speed railways in thousands of kilometers, certain country, starting in the year 2010. A quartic regression, so is used to model the length of the high-speed railways as a function. What length is predicted? So a quartic regression basically means that if you were to graph these points, 0, 1, 1, 7, something like that, there would be some kind of curve that would come close to these points. And a quartic regression means that it's ax to the fourth plus bx to the third plus cx squared plus dx plus e. So the higher the degree, the more accurate this thing can be. So what you do, now I don't have the calculator on the screen, but I'll just tell you what I'm doing on a TA calculator. I'm putting these 1, 2, 3, 4, 5 points in. If you have a calculator, you go stat, edit, and you put in 0, 3, 6, 9, 12 into L1. And then you put 1, 7, 16. You can hear the clicks. 25, 38 into list 2. Then you push stat. Go to the right for calculate. And number 7, it says quart reg. And you hit enter. And it's going to give me the equation. Now I'm going to store this. Where it says store reg EQ, I'm going to say vars, y-vars, function, y1. This way, I want to get the equation, which ends up being y equals 0.0036 x to the fourth minus 0.083 x to the third plus 0.68 x squared plus 0.58 x plus 1. Now when you plug 18 in for all these x's, you get 127 as your answer. Now, I stored the equation, and then I was able to just go vars to the right, y-vars, number 1, and number 1, and it made like a little y1, and then I just put parentheses 18. Now there might be another way to get this. I'm not sure if this is gonna work, but let's see. If I make the differences, 7 to 16 is 9. Now that's also 9. That's weird. No, I'm not gonna be able to do it that way. Okay, so this is the equation. You plug in, you get 127, which is the answer. Okay, here's a graph from 0 to 13. The endpoints are labeled A and E. The other extrema for G are B and D, and C is a point of inflection. Inflection is when it switches from a smiling graph to a frowning graph. Okay, they have TA, TB represent the x-coordinates. Which of the intervals is the rate of change of G? Rate of change decreasing is a fancy way of saying it looks like a frown. G is decreasing means it's going downward That's G decreasing. But rate of change of G decreasing is not the same thing. That's asking when is it frowning, which as we can see is in these two spots. Of the following, in which rate? So from C to E, so TC, can't see it that well. So this one, C to D and D to E. Basically, rate of change decreasing means the slope is getting less positive, 0, negative, more negative, more negative. That's the rate of change decreasing, and that's the answer to number 78. 79, we have a circle, we have a theta, radian, standard position, terminal array intersects the point. And they want to know what's the slope. They want to know what's the slope of this line. So this is the key here. Tan theta equals negative 3 over 4, which means that, so this is a little confusing and a little hard to explain, but basically, if you made a right triangle right here, this angle here, which I'm going to call alpha, it's not exactly the same as theta, because theta is this big angle that's practically 360 degrees, and alpha is known as the reference angle. It's related to it because if I made it up here, the tangent, the opposite over adjacent, would be the same thing, except it would be negative for this one, because the in quadrant 4, all students take calculus. Tangent is negative in quadrant 4 because the y coordinate is negative and the x coordinate is positive for that point. Basically, opposite over adjacent, TOA, SOHCAHTOA, is 3/4. Now, it's not really exactly 3 and 4. It could be like 3x, 4x, like it's something in that ratio, 3 to 4. So this is also, this is also 3 and 4, although this is like more like negative 3. So the slope is rise over run, so you go down 3 over 4, so it's negative 3/4. So the tangent is actually the slope. They're like the same thing. Number 80. A set of data is using a semi-log plot. So the way semi-log plot works is from like 0 to 1 is a certain distance, but from 1 to 10 is the same distance, and from 10 to 100 is the same distance, so it kind of like smushes stuff together. The semi-log is a decreasing linear pattern. What happens with semi-log is when you have exponential curve on the semi-log plot, it looks like a line. So if it's a decreasing linear pattern, that happens also with an exponential, but exponential decay. The function C models the cost, and it's given by this equation, where B is a constant. It's known that it costs $115 to produce 10 items. Wow, that's it. Oh, I see. This is sort of confusing. They want to know the average rate of change from 30 to 40. So you want to divide the difference of 1,000 plus 40B over 40 minus 1,000 plus 30B over 30. So we have all this to do. The problem is we don't know what B is. And they tell us a couple of things. It's 115 to produce 10 items and 65 to produce 20 items. So I think we're going to have to find what B is. Easiest way to do that is to pick one of these numbers like 65, 20, and just put in 65 equals 1,000 plus 20B over X, over 20, sorry. Multiply both sides by 20. 1,300 equals 1,000 plus 20B. subtract, get 300 equals 20b, and b equals 15, and then I'm going to plug in 15 for all those b's. That's what I think you do. And when you run this all through a calculator, you get negative 0.83 repeating, which makes it seem like the answer must be choice A. 82. From 0 to 2, the number of people inside a large shopping center is changing at a rate modeled by the function. So here's the equation. Measured in each unit is hundreds of people per hour. So that's a rate. So this is a graph of how the rate changes. Which of the following gives the time, t, and reasoning for when the number of people inside the shopping center? Interesting question. So t and p of t. Now, when you graph this thing on a graphing calculator, it's going to be a cubic. It might look something like this. And let's just, if it were something like this, the rate that people, this isn't the number of people coming in. It's the number of people is changing at a rate modeled by the function. So this is not people in time, it's the rate that people are coming in. So they're coming in they're coming in a lot per hour, more per hour, more per hour, more per hour, less per hour. So which of the following gives the reasoning for when the number of people inside, when the people inside are at the maximum? Okay, I got confused because I did not actually graph it on the graphing calculator, but now I did, and the graph looks something like this. It's real important that the graph looks something like this. It's going up to 2. Let's just see what the scale is on this x max. I'm just going to make x max 2 just to see. Okay, so from 0 to 2, it actually is only this much of the graph. Okay, so what's important, the reason it was important to make the graph is because of, and actually, now that I've zoomed in even more, it looks something like this. The reason why this is important is because at this moment, it's not that the number of people, it's not that people are coming and more people come and people are leaving. It looks a bit like that, but it's not people. It's rate that people are coming in time. So people are coming in at a certain rate, then more people are coming in. And now people are still coming in, but just at a lesser rate and a lesser rate. And right here is when people start to leave because now it's a negative rate. So basically, they're just asking what is the x-intercept of this graph. And to do that, you push second, and then you push trace, which is calculate. Then you go to the first thing, which is number 2, which is 0. And it wants left bound, right bound. So you click a point a little bit to the left of the x-intercept and a little bit to the right. And then you move close to it, and it tells you that the answer is about 1.445 is the x-coordinate. So that's either C or Z. Now they want the reason why, though. Because the rate of change changes from increasing. So it's not that the rate of change is increasing versus decreasing. I think it's because the rate of change went from positive to negative. That's what I think. when the rate of change is decreasing at that point. So it's not that it changes from increasing to decreasing. If anything, it might have changed from decreasing because it's going negative. Yeah, it's pretty confusing about that. But this is what I think the answer is, choice D. Okay, just 5 more questions. The table gives the values for a rational function. Rational functions are graphs that have some asymptotes and things. They look kind of strange sometimes like that. So it's a rational function. The polynomial in the numerator and the polynomial in the denominator of the function have no zeros in common. Based on the information given, which of the following conditions is possible for the graph of f? So imagine I were to make a little graph of these points. Notice how all the points are pretty close to 5. There's 5. At 5, it's undefined. But at minus 5.1, so close to 5, it's down here. And even closer to 5, it's down here at negative 100. And even closer to, sorry, this is all negative 5. So let me just, 1, 2, let's make that the axis. That's negative 5. So when I'm negative 5.1, I'm a little bit to the left of negative 5, and I'm down here at negative 10. And negative 5.01, I'm down at negative 100, which is even closer to negative 5. And then negative 5.001 is even closer. This suggests that there's this behavior like that. And then when you go a little bit to the right of negative 5, negative 4.99, the point's all the way up here at 1,000. And a little more to the right, negative 4.99 is here at 100. So it's suggesting this. So this is what happens when there's an asymptote, which is not the same thing as a whole, which is also undefined. But when that happens, when you're going from the left and right, it's going to the same place. This one's going to negative infinity and positive infinity. Saying they have no zeros in common is a way of saying there's no holes, because that's what causes a hole, when there's a 0 on the top and bottom that cancel out. So that is why the graph has a vertical asymptote at x equals negative 5. You can see when there's a vertical asymptote, you have this kind of thing going on where one side usually is going up towards it. The other side might also be going up towards it, but it's different from a hole where it looks something like that. Okay, so for question 84, we have years, 1.52, 2.53, 4, 6. And we have the pounds, it's going up. Something like that. So this curve is looking a little bit like a logarithmic curve. It's growing, but it's kind of growing kind of slowly. To get the equation for it, you can get a logarithmic regression. The way you do that is you go into your calculator and you say stat, edit, and you type in, you can clear out the lists, clear enter on the top of lists 1 and 2 especially. Sorry, I'm not able to show you what's going on there. But what I'm doing is I'm typing into L1, 1.5, 2, 2.5, 3, 4, and 6 into L1. And in L2, I'm putting 2420, which is 1 away from 2421, the address of the house I grew up in, 2421 Babylon Turnpike, 3150, 3615, 4105, 4835, and 6355. Then you just go stat, push to the right, calc, and one of the options is log reg, ln reg, number 9. So you hit enter. I like to store the equation. I push vars to the right, y vars 1, 1. This way, after I store it, I'll have the equation if it's complicated. Okay, it's telling me that the equation is y equals 1167 or 1167 times 2777.2778, I'll round it. Sorry, it's A plus B ln x. So now we just type 4.5 into that equation. Now I stored it, so I just say vars, y vars, number 1 again, and then parentheses 4.5, and it tells me the answer is 5345, which is choice D. I think there's just 3 more questions. Sorry for some of the errors on this. I didn't do this test. This is the first time I've ever seen these questions. So normally I'd go over them and do the test first and figure out all the kinks, but it's more spontaneous this way. The polar function 1 plus 2 cosine theta is graphed. On which of the following intervals is the distance between the point with polar coordinates and the origin decreasing? Okay. So theta r. So 1 plus 2 cosine theta, that's going to, when I graph the points, 0, cosine 0 is 1, so that's 3. Cosine of 90 is 0, so that's 1. Cosine of 180 is negative 1, so that's minus 1. 270 is 0 again, so that's 1, and 360 is like 0. So 0, 3 is out here. 91 is up here. 180 is in this direction, but negative 1 is there. 270 is 1. Now, these 4 points, it's good to know that this shape is, first of all, 1 plus 2 cosine theta, if I did 1 plus 2 cosine x, would be something like that. And what this generally does is causes a shape that looks something like this, called a limosone with inner loop. Yes, you could graph it. This is the calculator section now that I think about it. On which of the following intervals is the distance between the point with polar coordinates f, theta, theta, and the origin decreasing? So you see how, if I only zoom in a little bit, you see how this is kind of like a big line, and then this is like smaller, 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 smaller. I feel like from 0 to this, see, is potential answer. So is this. Because it's definitely getting smaller. It's going, like at 0 degrees, it's all the way at 6, but at 90, it's down to 1, which is pi over 2, which is about 1.5. But all the way down, it keeps getting smaller. So these aren't the answer. Now, 3.142 is basically pi, and you can see that since this curve goes like this, and then like this, at pi, which was 180, it was at negative 1, this inner loop here. At pi, it was negative 1, but then it comes around, and it's getting smaller. You see that? It's like spiraling inward, like that inner loop is something like this. So it's like this line, and then this is smaller and smaller and smaller and smaller. So that is why, I'll zoom out, I think the answer is C. There are 2 different times. Like if I draw this thing, it's far away from the origin or from the pole. It's getting closer as it spirals inward. So spiraling inward is where the distance between the point, on which interval is the distance between the point with polar coordinates and the origin decreasing. See, it's getting smaller. And then on the second half of this. See, now it's getting further. It's spiraling outward. But then it spirals inward again, so it gets smaller again. And then it spirals outward again. Weird question. Answer is C. There's no calculation. It's more of like a concept. 86. I think this is the second to last question. On a given day, the number of people that have entered a museum is modeled. Okay, so this one's people, but it uses trig. And T is measured in hours from 0 to 8. When did person 4,000 enter the museum? So what they're asking is, oh, it's measured in thousands. So they want to know, when does this equal 4? Well, two ways to do this question. We could graph this thing. However, that's gonna look somehow, something like that, and then graph 4 and see where they intersect. But I'm gonna do it the non-graphing way. Start by dividing both sides by 4.217. And 4 divided by 4.217 is evidently 0.94854. Now, what I like to do when I see a tan inverse is just take the tangent of both sides. And what that does is it kind of like, you take the tangent of left side and tangent of the right side, and the tan and the tan inverse kind of cancel each other out. Now, in my calculator, make sure I'm in radian modes, and I say tan second and, so that way I didn't round it all. And the left side turns into 1.394. So, whoops, that's minus. So then you add 0.026 to both sides. And divide both sides by 0.7. And you get T is equal to about 2.02868, which looks like it's B. Now, you could probably do this by graphing also, but this is the way I wanted to do it. The final question. 87. Okay, some kind of modeling. For T is between 0 and 16, which these all are, the rate at which customers arrive at a restaurant on a given day is modeled by the function. So this is another one where this is not the number of people, but it's the rate that people are coming. So like in this one, people are coming, they're coming faster, more are coming really fast. They're still coming, just not as 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 fast. They stop coming for a second. So just want to tell you, this is rate versus time. Modeled by the function where it's measured in customers per hour, and T is measured in hours since the restaurant opened. The function R is increasing. Oh, we want to get the function R to be increasing from 0 to 4, from 0 to 4. So this one is doing it. And again, from 8 to 12. So that's that. This is also going from 0 to 4 and 8 to 12. But this has to be decreasing from 4 to 8 and from 12 to 16, which this one is. Wait a second, the function R, yeah, interesting. So the function N, oh, there's a different function. The function N models the total number of customers who have arrived at the restaurant since it opened. So this is not what I thought this question was going to be about. I could re-film it, but I'm not, because it's good to look at how you look at a question and think what they're asking about. They want to know, so this thing seems to be the graph of how the rate is changing, but they want how the number of people are changing. So what's happening is, first people are coming pretty fast. No, people are coming pretty slowly in the beginning. But then people start coming faster and faster and faster, which kind of looks like that. And then people are coming really fast, but then they're still coming, but they're coming slower now. And that's where, whoops. So it's going to be one of these two. And then at 8, they stop coming from a moment. So you see 8 has a flat point here, and this 8 doesn't, and the answer is D. So that question is pretty weird. They're describing how the rate changes, but they're asking how does what would a graph of the number of people. This is a graph of time versus how many people are there. And this looks like a graph of time versus the rate that the people are coming in. So they're coming slowly because it's like close to 0, and the rate gets faster and faster, and then slower and slower. You say faster, faster, slower, slower, and then flat for 1 second there. Unusual question. That is, I never taught that question to my pre-calc before, but it's actually a pretty good calculus concept. Well, that's going to do it for this video. I hope you liked it. I'm not sure if I did, but if you did, that's all that matters.